Hi everyone. I want to give you a quick pick of LAB9, which is about images, as this is going to be a remote lecture conducted by the peer mentors. Some of you haven't gotten to the lectures about images, so it is a good idea that we review that together. So what is an image? An image is an element, is data that is composed by a pixel. A pixel is the smallest physical digital image representation. A pixel has three components. There are the red, the green, and the blue, or RGB. Each one of these components from the pixel is defined by the intensity of each one. Those values, the values that the RGB uh, components of the pixel can receive, they range from 0 to 255. So what happens is that with the different values that you can provide to the RGB, you can then create or recreate any kind of colors that you want. So for example, if you place 00 to green and blue and 255 to the red, you're going to get a pixel where the red is the maximum color and green and blue are not present, so the resultant pixel will be red. The same will happen if you do green 255 and 0 to the others, you get green, and if you get 255 to the blue, you get a blue pixel. But what happens if you get several colors at the same time with different values or intermediate values? Then that's where you can get another color. So here, for example, in the third line, we get 255 and 255 for the red and green. So we can create a yellow. Blue was 0. And lastly, if all the colors are present at the maximum value 255, then we get the white. So I guess you get the idea. So what happens when we have an image like the Batman that is presented here? Basically, we have thousands of pixels for or thousands of data that represent a color, and an image like the one for the Batman, it will have three matrices, one dedicated for the red, one for the green, and one for the blue. Each one of the values of those matrices will have values ranging from 0 to 255, and then with that you can create a specific color for every pixel. That's really important to understand. If you got to this point, then let's talk about really quick about what you have to do for this lab today. So basically, you're going to be working with a chessboard and working on solving the next possible move for three pieces in the chessboard. You got the bishop, you got the knight, and you got the rook. So with that, it might sound difficult, but it's actually very easy, and it is explained and in detail in the MATLAB grader. So for example, for the bishop here, um, if the bishop is located in the center as it is, the green X, represent the possible move that can be made from that position for the bishop. The bishop can move diagonal in the chessboard, which is size 8 by 8 blocks or squares of black and white. So in your case, it will be randomly generated the coordinates for the actual position. It is your job to make that pixel or that block to make a red where there is the actual position for the bishop. So from there, for example, in the first test case, the location is 4 4, so 1 2 3 4 to the right, 1 2 3 4 to the south, um, or down. Then you can get the position there. From there, diagonal starting from that red point, you need to draw those white squares. They have to become yellow. It's your job to do that. So for the test case 2, the locations are 5 and 6, and you can see what is the possible moves for the bishop. The same will happen for the knight. The knight, it has 8 possible moves depending where it is located in the checkerboard. So you have 2 test cases. You need to draw the actual position and the possible move. Notice that for this one, once the actual location is on the edges, you have to limit how many or where are the possible move that can take. Probably the easiest problem, once you understand the bishop and the knight, is the rook. This one moves horizontally and vertically. So it is the same problem, it's just the movement and possible moves are easier. Once you get to draw the checkerboard, it is kind of easy to get this problem, the logic, to work. If you have taken the lab or the lecture before, that's one of the problems that you have to solve during the lecture. If you haven't yet, or if you took the class many semesters ago, then I have a solution that we used in the past to draw this checkerboard, which has white and black squares. The image is defined 800 by 800 pixels, and you can see that is three-dimensional. It's 3 matrices that we need to create, and there are 2 for loops to get the rows and the columns, and you have to be mindful that you need to get odd or even for white and black, and they change. So here we go from II from 1 to 800, and JJ from 1 to 800 because that's the maximum size. And then when we are looping inside the loop, we go from II to II plus 99, and the same goes for JJ. And we do a conditional checking if it is 255 for the 3 colors, or 0, meaning will it be black or will it be white. So that's it. With that code, you can create a checkerboard like that, and then just work in the logic. You don't have that available in MATLAB Grader, but the code is here that you can type and use and reuse. Finally, I have several commands that can be useful as examples. These are available in the lectures that you can use. I won't talk about this, but I'm going to open now my MATLAB, and I'm going to show you how some of them work for creating the how we call it, the checkerboard, because that's the most important. You have to work in the logic.